So this is the informal method to finding the end behavior of rational functions. Basically, when we're looking at our rational functions, we'll have a numerator that's a polynomial divided by a denominator that's also a polynomial. And we can look at the degree of the numerator and the degree of the denominator. We're going to let n be the degree of the numerator and d be the degree of the denominator. Right? The degree is the greatest exponent of x, or of the variable in the function. So it boils down to basically if n is greater than d, there is no horizontal asymptote, right? If the numerator is growing faster than the denominator, because the exponent's bigger in the numerator than the denominator, it makes sense that that function is going to go off towards infinity or towards negative infinity. So there is no horizontal asymptote. There is an oblique asymptote, which means it's going to start approximating a different curve. And the degree of that asymptote is the numerator minus the degree of the numerator minus the degree of the denominator. And we'll talk about that in a moment. If the degree of the denominator is bigger than the degree of the numerator, that means the denominator is going to grow really fast. So we're going to take a relatively small number and divide by a huge number, so the horizontal asymptote is 0, right? We've discussed that a lot, where things get divided by a bigger and bigger number, so it approaches 0. If the degree of the numerator and the degree of the denominator are the same, then that means they're growing at the same rate, and so what it is, the horizontal asymptote will be the ratio of the coefficients of the term that determined the degree of the numerator and denominator. Okay, so that's a lot of information. You probably should take a screenshot of this and reference this, but this is the key to finding these things easily. So here's some examples. First of all, I just want to talk about the degrees. If we are looking for the degree of the numerator, we're looking for the exponent that's the biggest in the numerator and the one that's the biggest in the denominator. So if we look along the line, we'll see that, oh, this one here is 1 and this one here is 2. And we look along the line, we see a 3 and a 3. So we can see that the numerator is bigger than the denominator is bigger than the numerator, and here they are the same. Just so that we can see it as well, the coefficient of the degree term, in this case is 1 and 20. The coefficient here would be -3 and +3, and the coefficient here would be 2 and 5. Picking out that information should be pretty quick. All right, so let's just talk about this. We look at these, we look at the degrees, we go, oh, 3 is greater than 2. Therefore, no horizontal asymptote. And there is an oblique asymptote. Of degree 3 minus 2, which is 1. So that means that basically we are going to have an oblique asymptote going, which means, although we haven't talked about it yet, degree 1 is a straight line. So then our function off towards infinity is going to approach that straight line, but it's still going up towards infinity. Okay. This next one here, we look and we go, oh, degree 1, degree 2. So the denominator is greater than the numerator. The coefficients don't even matter. So we say the horizontal asymptote is that y equals 0. And then the last one we look and we go, oh, degree 3. Because they're the same, we look at the ratio of the coefficients. So we look at this 5 and this 2. This is the first time we've had to do that. So the horizontal asymptote is y equals 2/5. And that's it. Very good.